Alrighty, we are back with actually the last lesson in this particular unit. So remember, we're solving polynomials with imaginary solutions. And today we are going to solve by using the quadratic formula. So the quadratic formula is used to solve quadratics when factoring isn't possible or when you can't just take the square root. So we use this formula. There are songs, there are raps, there are little sayings to help you memorize quadratic formula. You might remember this from your previous algebra class, but it's x equals the opposite of b, or negative b, plus and minus the square root of b squared minus 4ac. All of that is divided by 2 multiplied by a. All right, and here we go. Let's get to it. So the discriminant is part of the expression or part of the quadratic formula, and it's the expression that's underneath the radical symbol. It's the b squared minus 4ac. This portion of that formula will actually tell you the type and the number of solutions to your quadratic equation. So we can have two different types of solutions. One that we can get is if our discriminant is greater than 0. So if it's positive, then we will get two real solutions. So we'll see it cross the x-axis in two different places. If the discriminant, b squared minus 4ac, equals 0, then we will get one real solution. That just means our graph would only touch or cross the x-axis in one place. If the discriminant is less than 0, so if it's a negative value underneath the square root, then we'll have two imaginary solutions. And we're going to practice and see several of these examples. All right, so in our first example, example 4, 2x squared minus 5x minus 12 equals 0. This is exactly how we want our equation to look so that we can use the quadratic formula. Our first step is to always set the entire equation equal to 0. Then make sure that we've done that we have it in standard form so we can use the a, b, and c values from ax squared plus bx plus c, that quadratic expression or the quadratic equation. We'll use those values to set up our quadratic formula. Then we'll simplify just the discriminant. And the reason we do that is so that we know the number and type of solutions, and we'll know if it's imaginary to factor out the I before we simplify the square root so that we can solve for x. So in this example, our a is 2, b is negative 5, and c is negative 12. And remember, the quadratic formula is the opposite of b, plus and minus the square root of b squared minus 4 multiplied by a and c, all divided by 2 times a. I've already gone ahead and simplified each of the values of a, b, and c into the quadratic formula, and then we will just work with the discriminant, that negative 5 quantity squared minus 4 multiplied by 2 and negative 12. So when we simplify just the discriminant, the stuff under the radical, that simplifies to give us 121. Okay, so in my next step, I actually go ahead and write x equals 5 plus and minus the square root of 121, all divided by 4. And I'm simplifying bits and pieces as we go through. We do know the square root of 121. It's a positive value. It's going to give us two real solutions. And the square root of 121 is both positive and negative 11. So x equals 5 plus and minus 11 divided by 4. I'm going to go ahead and separate that into two separate equations so I can determine the solutions individually. 5 plus 11 divided by 4 will give me 16 over 4, which is 4. And 5 minus 11 divided by 4 will give me a negative 6 over 4, or negative 3 halves. So our two solutions are positive 4 and negative 3 halves, or negative 1.5 for this example. All right, continue on. Number 5, 3y squared minus 3 equals negative 2y. Don't worry about the variable being different. We're just showing you can use different variables. We're still going to be solving for the place where the graph would cross the x-axis. We want to set it equal to 0, use a, b, and c to set up our quadratic formula, simplify to the discriminant, and then simplify farther to solve for x. In our first step, we do need to add that 2y term and put that entire equation into quadratic form, where it's the quadratic term, the squared, then the linear, and then the constant. So 3y squared plus 2y minus 3 is 0. Our a value is 3, b is 2, and c is negative 3. Substitute those values into the quadratic formula. Negative 2 plus and minus the square root of 2 squared minus 4 multiplied by 3 and negative 3, all divided by 2 times 3. When we simplify the discriminant, 2 squared minus 4 multiplied by 3 multiplied by negative 3, we get a value of 40. So we can rewrite our expression as negative 2 plus and minus the square root of 40, all divided by 6. Now we're going to simplify the square root of 40 and then process through. Negative 2 plus and minus 2 square root 10 divided by 6. And in this case, we can't combine any of the terms because we have that square root of 10, but we can reduce the negative 2, the positive 2, and the 6, all dividing by 2, giving us our two solutions of negative 1 plus and minus square root of 10 all over 3. All right, moving. Alrighty, our next example is 15x squared minus 5x equal to 0. As we go through that process, this example is already set equal to 0. So we're going to list the values of a, b, and c to use the quadratic formula, set it up so that we can simplify the discriminant, and then finally simplify further to solve for x. So our a value is 15, b is negative 5, c is 0. Setting up our quadratic formula, we get x equals 5 plus and minus the square root of the quantity negative 5 squared minus 4 multiplied by 15 multiplied by 0 all over 2 multiplied by 15. The discriminant will be negative 5 quantity squared minus 4 times 15 times 0, which actually just simplifies to give us 25. So we get x equals 5 plus and minus the square root of 25 all over 30. We know the square root of 25. That is a positive discriminant. That's going to give us two real solutions. So it's 5 plus and minus 5 over 30. Again, I'm going to take the extra step and write them as two different equations. X is 5 plus 5 over 30, and x equals 5 minus 5 over 30, giving us 10 over 30, or 1/3, as one solution, and 0 over 30, or 0, for the second solution. So our two answers are positive 1/3 and 0. Now, some of you could have seen from the get-go that the two terms, 15x squared and 5x, just had a GCF, and you could have just factored out a GCF and written this as 5x multiplied by the quantity of 3x minus 1, set each of those factors equal to 0, and solve to get 0 and 1/3. Okay, so whichever method you choose for this example is the one that you use. Whichever one you see to work or you're most comfortable with. You can go either way. But good job with this one, guys. Okay, here is example 7, x cubed minus 8 equals 0. Right off the bat, I notice this one's a little different because it's raised to the third power. If we're solving quadratic using the quadratic formula, I can only have it to the second power. All right, so we've got to figure out how to simplify this to get it to be an x squared equation. We're going to factor. Do you remember the cubes? I know, like second week of school, it's been forever, but this is a perfect cube. It's actually a difference of two cubes. So we're going to take the cubed root of the first and the last terms and keep the same sign. So our first factor is x minus 2. We're then going to square the first term, x squared, multiply first times last, 2x, and square the last term, 4. That's how we get the original equation to be a linear factor, x minus 2, multiplied by a quadratic factor, x squared plus 2x plus 4. Since these factors are multiplied together and equal 0, zero product property states that I can set them individually equal to 0 and solve. So if x minus 2 equals 0, When I solve for x, I just get 2. Cool, that is one of the 3 solutions. For the next one, x squared plus 2x plus 4, we are going to use quadratic formula. Anytime you're solving a sum or difference of cubes, you'll get one linear factor, x equals 2 in this case, and another one that's going to give us 2 imaginary solutions. So, using our a, b, and c values, we will get x equals -2 plus and minus the square root of 2 squared minus 4 multiplied by 1 and 4 all over 2 multiplied by 1. Remember, simplify the discriminant. 2 squared minus 4 times 1 times 4. That'll give us a -12. We have a negative discriminant, so we will get 2 imaginary solutions. So let's further rewrite our quadratic formula to be x equals -2 plus and minus the square root of -12, all divided by 2. We're going to simplify that square root of -12 to be 2i square root 3. So x is -2 plus and minus 2i root 3, all divided by 2. I can simplify the -2, the 2i, and the 2 in the denominator, giving us the final 2 solutions as x equals -1 plus and minus I square root 3, or 1i square root 3. There are the 3 solutions for this example. All right, great job. Let's keep going. All right, here we go with number 8. 3r squared minus 16r minus 7 equals 5. We do need to set it equal to 0 by subtracting 5 on each side of the equation. That gives us 3r squared minus 16r minus 12 is 0. You can now use your values of a, b, and c, 3, -16, and -12 to set up your quadratic formula. And that will give us x equaling 16 plus and minus the square root of -16 squared minus 4 multiplied by 3 and -12, all divided by 2 multiplied by 3. Remember, simplify the discriminant. -16 squared minus 4 multiplied by 3 multiplied by -12 will give us 400. Since our discriminant is positive 400, that means we'll have 2 real solutions. All right, here we go. X is 16 plus and minus the square root of 400 over 6. The square root of 400 is 20. So I'm going to write 2 different equations, x equaling 16 plus 20 divided by 6, and x equaling 16 minus 20 divided by 6. The first one, 16 plus 20, gives me 36, and 36 divided by 6 is 6. And our second solution, x equals 16 minus 20, that gives me -4 divided by 6, which simplifies to be 2/3. So our 2 solutions for this example are 6 and -2/3. Great job, guys. Keep going. All right, number 9. Solve by factoring or using quadratic formula. X cubed minus 4x. Okay, we are back to seeing that x cubed term. So we always are going to get up to 3 different solutions when x cubed is your largest exponent, and we're always going to want to try to factor if we can. I do see a GCF. Both of the terms are divisible by x, so I'm going to factor out the x first, and then I'll continue checking to see. So when I factor out the x, I get x multiplied by the quantity of x squared minus 4. All right, now in this case, you can solve by factoring as I've listed. You could do quadratic formula, or you could solve by taking a square root. You have several choices. We are going to set both factors, x and x squared minus 4 equal to 0, but I went ahead and factored it first. So it's the GCF of x multiplied by the quantities of x plus 2 and x minus 2. That comes from factoring the difference of 2 squares, x squared minus 4. Then I can set all 3 of those factors individually equal to 0 and solve for them separately. X will equal 0. X will equal x plus 2 is 0, so x equals -2, and x minus 2 equals 0, so x will equal 2. 0, 2, and -2 are the 3 solutions for this example. All right, we've got just a couple more, so we're going to go to probably about a 20-minute video this time. Just stick with me. In example 10, again, we have another cubic polynomial. This one, though, has 4 terms, and I still have to set it equal to 0. So x cubed minus 3x squared plus 4x minus 3 equals 9. We are going to subtract 9 on both sides to give us x cubed minus 3x squared plus 4x minus 12 all equal to 0. We haven't done a lot of factoring by grouping, but you might have in previous classes. So quick review, when factoring by grouping, we are going to group the first 2 terms, keep the sign, or keep the plus sign in between, and then group the back 2 terms, keeping the sign with that 3rd term. And then after we've grouped them, we're going to find the GCF of each of those sets of parentheses. Okay, double bubble, factor by grouping. The GCF of x cubed and negative 3x squared is x squared, leaving with a factor of x minus 3. 4x and negative 12 are both divisible by 4, so factor out a positive 4, leaving us with that same factor, x minus 3. So then we're going to regroup x squared plus 4 multiplied by x minus 3. X minus 3, this factor at the backside, like that's easy. You can solve that, set it equal to 0, and you'll get a 3. The other one, x squared plus 4, when we set it equal to 0, easiest way is probably going to be to take the square root. I've only got 2 terms. I can subtract the 4, and then I can take the square root on both sides. That will give us 2 imaginary solutions, and then if x minus 3 equals 0, we get x equaling positive 3, the one real solution. So I do have 3 different solutions, 3, positive 2i, and negative 2i. Great job. We got just a few more to go. Number 11, x squared equals negative 25. If you'd like, you can set it equal to 0, and you could use your a and c values because you wouldn't have a b. There's no x term or no linear term. And you could find the discriminant and then solve for x. But I see this one as a previous lesson. X squared equals a negative number. X squared is isolated. I'm just going to go ahead and take the square root. So square root of x squared equals the square root of negative 25. So x will equal both positive and negative 5i. Great. All right, and our last example, another, let's see, 1, 2, 3, 4, quartic or 4-termed polynomial with the largest exponent of 3. So we're going to get up to 3 different solutions. And just like we did in example 10, we are going to factor by grouping. Group those first 2 terms, x cubed and 2x squared, group the back 2 terms. And remember, our whole goal is to find those GCFs of each set, giving us an identical twin factor. The first 2 terms have x squared in common as their GCF, leaving us with x plus 2. The second 2 terms, if you divide or factor out a negative 9, that'll give you a positive x and a positive 2 left in parentheses, which is what we want. I want my GCFs to become a factor, x squared minus 9, and that identical factor to be the other one, x plus 2. X squared minus 9, you can set it equal to 0. You can solve by factoring. You can solve by taking the square root. Totally your call, your choice. X plus 2, set it equal to 0 as well, and just quickly solve for that one. So for x squared minus 9 equaling 0, I decided to add 9 to the other side and take the square root to give me positive and negative 3. And then if x plus 2 equals 0, I'm going to subtract the 2 to the other side and get x equals negative 2. Great job with all this work. This particular example had 3 real solutions. All right, so you've got some practice that you guys can do, and then you'll also have, like I said, quiz at the end of this week and your test next week. Great job, guys. Thank you, and have a great day.